Hey everyone, finally going to get around to building this MicroMax slope glider. I did a couple of, maybe just one video on this kind of overview. But now I'm going to build mine, so I'm starting out with the fuselage here. And I ran into a small problem. This is the servo tray that's provided. It's a piece of carbon fiber plate. It's cut out really well, and it's cut out for X06s, and it even has holes drilled for the mounting screws. Fits good in the fuse, but the problem I had was this, that when I put that tray in here and put an X08 in, I basically pushed it all the way down till the servos were touching the bottom of the fuselage here, the output shafts were sitting pretty high, and this push rod, you know, it only goes so high because it has to clear, or it's restrained by this part of the fuselage, right? So I just didn't see how it would work because I'd have to bend these push rods like this, you know, to get them to work. So I've gone with X06s, which are a little lower in profile. And in order to use those, I had to make a new servo tray, and I just made a really simple one, 3D printed plastic tray. You can see it right here, and it's got the X08s in there, and the holes for the mounting, and you can see, well, maybe you can't. Let me see. These ends are beveled on both sides, and that's just so that when I epoxy it in, there's more surface area on the tray, so it just doesn't glue to the top edge. It will drip down in there and get more surface area. So okay, I'm just going to go ahead and try to get this tray installed, and then we'll look at doing the push rod linkage and all that. Okay, I got the tray in there. I just tacked it down with just 4 small drops of CA, and then I put a bead of epoxy in there, and the epoxy has a little bit of black pigment because I was doing a repair on something else, so I just had that mixed up and ready to go. So we'll let that dry, and then what I've done also is I have scuffed up this V-tail joiner and cleaned it off with alcohol. Same with both of these control horns for the V-tail, and then on the V-tail themselves I have scuffed up the area that the horn mounts on and cleaned that off with alcohol. So we have a few things to glue together now, and I'm going to see how this goes. Forgot to mention that I also sanded in here with this slot in the fuselage where the V-tail joiner goes. So I roughed all that up and cleaned it with alcohol. And I've actually attached the control horn on both the V-tails. So what I did was I basically just used a small drop of CA to tack it on, and then I went back and put some epoxy over that. There's not a lot of gluing area, so I'm slightly concerned, but it should be okay. And when this is dry, I will clean this up with some with a file or some sandpaper, make it look a little nicer. And I did put the masking tape on here to keep the epoxy in check. So both those horns are glued on, and now I have to do the V-tail joiner, and that might be a little tricky, but we'll see how it goes. Alright, well, as you can see, I put some masking tape around the slot in the fuselage, and then I put the epoxy in the slot and pushed the V-tail joiner in there. Now I'm going to mount the V-tails, and kind of assuming everything's going to line up, but I will mount the wing too and double check, make sure the angles are all correct on the V-tails, and I did cut the holes open for the joiner so I could push the tails on. So I'll go ahead and do that. So it's all together basically. I got some masking tape holding these tails on. I'm trying to suck them down as tight as I can to the boom, because it you could glue this on a little crooked if you didn't make sure that the V-tails are fully seated and you let the epoxy dry. So I got a ton of tape going on here, trying to hold everything together, and the wing is on, and I gave it the old eyeball test and it looks pretty straight to me, so I'm happy with that. So we'll just basically let this dry overnight. And then since the horn's on, we should be able to, since the horns are on, we should be able to get the push rods in and hook up the servo arms. And yeah, get them working, get the V-tails working, and then we can move on to doing the servos and linkage in the wing. Okay, the epoxy's dry on my servo tray here. 3D printed servo tray, and the servos are bolted in. And then if we go in the back, we got the horns are on there, the joiner is on there. You have to be careful with these horns. I kind of maybe rushed it a little bit. See if I can get a good angle on this for you. This push rod has to go, I'm guessing it goes like this, right? In between the horn and the fuselage. And on one side it was fine, it seemed like it would work out fine, and on the other side it was too tight. So the angles were slightly different, so you need to, and I think that's just, you know, sloppy on my part gluing it in. So you have to pay attention to these horns when you're gluing them in and make sure they're at the right angle and you have a gap big enough to get this push rod between the horn and the fuselage. So with that being said, oh, also let me take off elevator or V-tail. I had to do a little bit of work on this V-tail. Basically I had to use a Dremel with a sanding drum and grind kind of like an angle on this control horn, this carbon fiber control horn, because it was hitting the fuselage during up elevator deflection. So I don't know if you can, this thing will zoom. See that? A little bit of grinding. That horn's pretty thick anyway, it's kind of overkill. And then I also did a little bit of work on the fuselage here, and I ground a little kind of half moon there to get more clearance. So if I move this one up, you can see the horn kind of hits it there, not a big deal. So the next thing I gotta do is put holes in for the push rod exits. Alright, so what I did was I just stuck the V-tails on like that, and I just drew a line. I put some masking tape down and I just drew a line there, and that's going to mark my push rod exit. And I'm going to go as far in with the hole as I can, so I basically want this push rod kind of laying against the surface when it comes out. So I need to drill these holes and try to feed the push rods through. Okay, jumping ahead a little bit, I did get these push rods installed, or so I thought. I had to put a little bend at the end of this to get up to the servo arm. It went okay. There's the back, an L bend for the control horn. I thought everything was going well, but when I actually glued the plastic outer tubing in place and got everything hooked up, the push rods became super tight. there's just a ton of drag on these, and I think way too much for these little servos. Probably encounter double centering problems and maybe even damage the servos. I did both sides and they both ended up the same, so I was kind of scratching my head about what to do. I had already made the control horns, and I think I zoom in here. I actually drilled real small holes, or 1mm holes. You can see it's actually into the hub part here, so they're about maybe 4mm from the center. And I drilled these out with a 1mm bit because the push rods are 1mm. The control horns and the tail, they come pre-drilled to 1mm. So I don't know, I was debating whether to use pull springs instead, but I thought maybe being a slope glider, maybe you know, I could encounter flutter issues. And the plastic tubes are already glued in, so man, what a pain. And I just kind of rifled around what I had laying around, and I found some, I think this is 1/32 inch stainless steel wire, or piano wire. It's 0.082, or I'm sorry, 0.82 millimeters. And this stuff that came with the kit is 1mm. So this works a lot better in the plastic tubing, but I have now some slop because the holes are drilled out to 1mm. So what I'm going to try to do is address that slop. I'm going to try to install these smaller rods and try to take up some of the gap with maybe some CA on the control horns, on the tail, and these servo arms. So I made up just a little remnant of the 32nd inch rod, and I kind of sharpened one end, and I'm going to slip this through the control horn like this and attempt to get some CA in there with it, and hopefully make a little bit of a bushing. So I'm going to put a few drops of CA on the end of my X-Acto knife here. And just going to put some on the rod. And just push it through a little bit. Like that. Hit it with some accelerator. That's kind of what that looks like. So we'll let this dry, and then I'm going to grab it with some pliers like this and just try to pull the horn off. Let's see if that closed the hole up any. May have tightened it up a little bit. Well, doing the CA trick didn't work quite well on the plastic horns, but it did work very well on the carbon control horns on the tails. So I did this one already, and it did a really good job of making a little bushing in there. I have to do the other side. So I'll just do the same thing. I'll just run a piece of rod through here. And I just put a drip of CA on it. And just push it through like that. Kind of got to try to hold it perpendicular. So I think that's going to work really well on the tails, on the servo arms. I'm going to go ahead and just put the push rods in and hook everything up and try to put a drip of CA in here after the L bends are hooked up, and hopefully that'll take up a little bit of the gap, and then when I move the servos it should break free and hopefully create some kind of bushing. If I manage to take the slop out of the V-tails and there's a little bit of slop in these control horns, that'll be okay with me. I can always make new servo arms later if things don't work out, but I'm going to try to salvage these for now. Okay, I have one end hooked up at the tail, so I put a little L bend in here, and it's in the control horn. The arm is on the servo, and now I have to make the bend for the servo arm. But as you can see, the rod needs to come over a bit, so I am going to actually put a bend in the rod to kind of alleviate some of the strain. But first, I'm going to make sure the tail's somewhat centered, and then I'm going to mark on the push rod where the servo hole is. And then what I'm going to do is disconnect the tail. So hopefully this will come out for us. Like that. Push that forward a bit. And then I need some needle nose. And just put a little bend in it. I need to do it just a touch more. I hate bending push rods. I mean, a straight shot is always the best solution, but I don't know how to do it with this plane, so it's pretty compact fuselage. And I think that'll give me a decent result. So I'm going to put the tail back on. And of course it's not wanting to cooperate. There we go. Again, we'll center the elevator. And we're just going to double check where our mark is and see if it's still on center, and it looks like it basically is. So now I have to try to put an L bend here, and how am I going to accomplish that? That's the question. I think what I'll do is cut some of this off. And I'm just going to try to make this bend basically with the push rod in the model, so looks okay. And then cut off some of the excess here. Okay, hopefully that works. Otherwise I'll have to make a whole new push rod. There we go. That's installed. And the tail is slightly up. So we need the push rod to be a bit shorter, actually. I could probably do that by bending it a bit more. Actually, let me get the servo tester out. Let's just see what we got here. So that's where it wants to center. I'm not really happy with that arm. Okay, well I put a couple of bends in there. You can probably see, because I had to get the push rod to come up to the servo arm and then level off. So you can see how the bends are. Kind of comes up and then goes level again and then down, because the push rod level is below the servo arm. And seems to work pretty well. Again, this dimension here is looking to me like 3 to 3.5 millimeters. That's the distance from the push rod to the center of travel, which is super tiny. But if I show you the actual tail movement, there's up and down. So I think we get plenty of travel with that super tiny horn, and we're using most, if not all, of the servo travel. So it's the best thing I could come up with to keep the resolution of the servo high and to keep the thing from hopefully not double centering. So that takes care of that side. I have to finish up the other side, so I'll probably just do that off camera. Okay, one thing I want to cover real quick, if you're gonna kind of copy me when you do this build, you want to make sure that the L bend for your servo arm doesn't really stick past the bottom of the arm. See, that's poking out about 2 millimeters. I gotta trim that down because that's gonna drag on the case of the servo, and we don't want that. So yeah, make sure it's basically flush with the bottom of the servo arm. So I'm gonna go ahead and just trim that a little bit down so it's flush. So I think I got the push rods basically done now. L bends are in the arms, servo arms here, and the tail's hooked up. Obviously, since these are just L bends, they can easily pop out. So I need to come up with something to retain the L bends in and ensure they don't come out in flight. So I'm thinking I'm going to 3D print some kind of strap or something that goes over here and I can glue on to the fuselage. So it's going to require a little bit of measuring and some design work on the computer, and then we'll see what we can come up with. I think I've come up with a great solution to hold these L bends in place. I designed and 3D printed a little cap that bolts on top of the servo arm. So we have a 2mm threaded 2mm machine screw going into the output shaft, which is longer than the standard screw. So this is the standard screw right here, so it's about 3mm longer. And then I have a 1.4mm tapping screw going into this hole of the servo arm, and it basically locks the L bend in place. And if I can try to show you what this little thing looks like. It's basically a flat plate with two lugs coming off of it, and I'll actually leave a link in the description to my 3D printed servo tray and to this part here if you want to use these parts for a MicroMax or anything else that you might be building. You feel free to download and print them out. Yeah, so pretty happy with the way that came out. I'm going to go ahead and finish up this servo here, and that should wrap it up. Okay, I got both my little L-bend keepers attached to the servos, and I'm super happy with the way that came out. That looks nice and clean to me. I get all the movement I need, so happy with that. These L-bends aren't going to go anywhere. Everything's secure. I think that's going to wrap up the fuselage video. I still have to put like a 4-pin connector right here for the wing wiring, but I'll do that after I finish the wing and when I get to doing the receiver and battery install. So for now, that's going to wrap up the fuselage. You know, honestly, I don't like the push rods on this. I think the tolerance between the inner diameter of the plastic tube and the, you know, the 1mm steel wire is too tight. The inner diameter of the plastic tube is probably 1mm and the steel wire is probably 1mm. And you put any kind of a bend, even a gentle bend, in the tubing, you know, because you have to get a bend just to reach the servos, even a gentle one. So it just makes it tight and sticky, and I don't like it. So what I would say, if you get one of these, I would right off the bat switch to a slightly smaller diameter inner wire, like 1/32 or something like 0.8 millimeter in metric if you can find it, or get yourself maybe some Teflon tubing instead of this white plastic stuff, you know, and try to get like a tubing that is slightly bigger than 1mm on the inner diameter, and I think you'll have a much easier time putting the push rods in. I basically had to do all this twice because I did it with the wire that it came with, and I had to do it again with some different wire, so it was a pain in the butt. Didn't really like it. Servo installation is tight, as you can see. Really important to use the shortest arms possible, otherwise you're not going to use hardly any travel in your servos. The tray is cut out for X08s. I don't see how they could fit, because again, you'd be making the push rods bend even more because they sit up higher than these X06s. So I made my own tray for X06s. Again, if you want to download and print that tray, it'll be in the description below, as well as these keepers. So Thanks for watching. That wraps up this part of the MicroMax build. Next time we'll get into the wing, and I hope you guys enjoyed it, found some of this information useful, and I will see you in the next one. Thanks.